Hello dear students, I welcome you back for another lecture on the topic electric charges and field. So in the previous class we had studied electric field due to a dipole along the axial line. So today also we are going to do one more important derivation, that is electric field due to a dipole along the equatorial line. So if you remember, what is a dipole? Dipole is a set of two equal and opposite charges separated by certain distance. That is called as electric dipole. And what is electric dipole moment? It is nothing but product of either of the charges and the distance between them, denoted by P. And how do we calculate it? Q 2 into A. So today we are going to find electric field due to a dipole along the equatorial line. When I say the word equatorial line, it means a perpendicular. So again I have a dipole, and that dipole is responsible to generate certain electric field. As I told you earlier, the net charge of an electric dipole will be 0. But whereas net electric field due to dipole will be never 0, because two charges are separated by certain distance. So today we are going to find again an electric field but along the equatorial line. So consider if I have two charges, plus Q and minus Q, plus Q. Okay. Consider I have two charges. Shall I erase this? So here we are finding electric dipole along the equatorial line. So consider two charges, plus Q and minus Q. It is a set of two charges, yes or no? They are separated by a distance of 2a. As I told you, you can take it as 2L, 2D, also 2R. In different textbook you will find different denotation. This is the dipole axis and this is the dipole center. So as you know this distance will be A, and this distance also will be A. Now is it not a dipole? Yes, it's a dipole. Two equal and opposite charges separated by certain distance, that is dipole axis, will constitute one electric dipole. Okay, and product of the one of the charge and the distance between them will give me what? Electric dipole moment. Now you know that this is the charge, and this charge will be responsible to generate a space around it, and that space is known as electric field. And how do we represent in terms of electric fields lines? Now these two charges will together compromise and form one electric field, and that electric field will be in all the three dimensions. Okay, but here they are asking you to find electric field due to this dipole in an equatorial plane. So they want to know what is the electric field at this point P. So if I draw a line here, this forms a 90-degree angle with the dipole axis. Okay, so this will be 90 degree. Now students, this charge will generate electric field E1, and this charge will generate electric field E2. Look at those charges. This is positive, this is negative. Already you know that electric field lines will be radially outwards for this, and electric field lines will be radially inwards for this. Now let me draw a right angle triangle from this. Okay, so this will be electric field E plus Q, or let me give a electric field name as E1. This is electric field E1. Now students, we are interested to find what is electric field at this point P. Now you know that if I extend this line, this will be E1. Same thing from here. I'll draw a triangle, right angle triangle. This will be theta, as well as this will be theta. I'll give this labeling as A, and this is B, and this point as C. Okay, I don't want C. Let it be P only. Now students, this is very important. This, since it is a positive charge, the electric field lines will be radially outwards, and this charge, which is negative charge, its electric field lines will be radially inwards. And if I now students, look here carefully. This line is the resultant field due to plus Q, and this is the resultant due to minus Q. Now can I resolve this vector into two components? Yes or no? See, if you have studied law of parallelogram of forces or rectangular component of resolving the vectors, so you have seen that first here, if one body is here, maybe of 1 kg, and one object or force has been applied of 1 Newton in this direction, and one more force is applied in this direction, 1 Newton of force. So where does the body should go? Will the body will go in this direction? No. This body will keep quiet. 1 Newton force will keep quiet. No. The body also will be pulled here. So what will happen? The body will neither go in this direction nor neither it will go in this direction, but body will choose the third direction, that is the resultant. So if you remember in first year we have resolved the vectors. Vector P, this is vector P and this is vector Q. Vector P plus Q give you the resultant vector R. And when you draw, you got a rectangle or else parallelogram. So similarly, this is the resultant. Now similarly you can look here, this is the resultant. And how do you get resultant? When two components acts in one particular direction. So E is the resultant. So can I resolve these components into parallel components and perpendicular components? So this will be E1 sin theta and this component will be E1 cos theta. Are you understanding? So if this is E1, this will be E1 sin theta and this will be E1 cos theta, the vertical component as well as horizontal component. Now same thing here. This is the vector. This is the resolved vector. Electric field E2. I'll give a name as E2, which is due to minus Q. Now this E2 is a vector, is a resultant. Now how do you get a resultant vector? By when two force acts into this direction. So one will be the vertical component and one will be the horizontal component. So can I write this as E2 cos theta and this component as E2 sin theta? Just look carefully here. What I have done here is I have resolved this electric field E1 and E2 into vertical components and horizontal components. So for E1, what did I got the components? E1 sin theta, E1 cos theta, which was in this direction. Now E2, why E2 is shown inwards? Because of minus, which is radially inward. Now E2 will be what? E2 sin theta and E2 cos theta. Have you understood this? Now students, look carefully here. Whatever the electric field at this point P I am getting, it is only because of these two components. The horizontal component, not the vertical components. Because these vertical components are equal but in opposite direction. So E1 sin theta and E2 sin theta will cancel out because the magnitude of the charges is same. So E1, whatever E1 electric field is generated, same is generated by E2 but in opposite direction. So as a result, E1 sin theta and E2 sin theta cancel out, and whereas the horizontal components get added up. So E1 cos theta plus E2 cos theta will give me a resultant electric field E. So here we understand very important thing is that whatever electric field is generated at the equatorial point, it is only because of the horizontal component, because the vertical component cancel out each other. Have you understood the diagram? Okay, in exam you should be able to write the consideration also. Consider a dipole separated by a distance 2a having a charges plus q and minus q. Then let P be a point of equatorial. That way you should be able to write the consideration. So shall I erase this? Okay. Now let us begin with the derivation. Students, see this is one of the most important 5 marks derivation. If not derivation, definitely problem will be asked from this section. Now again same thing what we have done in the axial line. Now electric field due to plus q charge, let me give a name as E1. E1 was, what was E1? 1 upon 4 pi epsilon naught q divided by AP square. Was it not a AP square? If you look into the diagram, this was A, this was P, this was B, and I'll give this dipole center as O. So electric field due to plus q, 1 upon 4 pi epsilon naught q divided by r square. What is r square? R square is this distance, AP square. This was the distance r. So this is AP square. Remember, this distance is A, this distance is r. So what is electric field due to plus q will be 1 upon 4 pi epsilon naught q divided by AP square, which is this distance. Similarly, can I reduce this AP square and directly write it as A square plus R square by using Pythagoras theorem? If this distance is A, this is R, what will be this distance? Sum of the square will be what? AP square will be equals to what? Sum of the square of the other two sides, A square plus R square using Pythagoras theorem. So instead of writing AP square, shall I write directly as A square plus R square? Yes. Similarly, electric field due to minus Q, which was E2. E2 what do you get? 1 upon 4 pi epsilon naught q divided by bp square minus q divided by bp square. Now students look here, we'll just take the magnitude of the charge, we'll not take the nature of the charge, we'll just take the magnitude of the charge. I'll tell you what is the reason for this. Now this distance is again bp square. So again using Pythagoras theorem, this is a, this is r, what is this will be a square plus r square. So this will also will be equal to what? A square plus r square. So this equation 1 and this is equation number 2. Now both are equal, right? Now if you resolve those components into vertical components and horizontal component, what did I get? Electric field E is equal to E1 cos theta plus E2 cos theta. Yes or no, students? Now why? Because the vertical component cancelled out each other. So E will be equals to what? Shall I take common? E1 plus E2 into bracket cos theta. Will it be better to write E equals to 2 times E1 cos theta? Because here E1 is equal to E2. Look at equation 1 and 2. Are they both same? Yes. So instead of writing E1, E2 here, shall I write again E1? So E1 plus E1 will get me what? 2 times E1 cos theta. So whatever is the electric field generated here, it is only because of the horizontal component. So have you understood why I have written here E1? Because E1 is equal to E2. Clear? Now here very important thing is, what is cos theta here? Cos theta. Now students, if you remember, again you have to refer the diagram. This was A, this was O, this was P, this distance was A, this distance was R. Okay, you have to find this. So cos theta will be what? Cos theta will be what? Is it not a adjacent upon hypotenuse? So OA divided by OP. Yes or no, student? So what is OA is equal to A? What is OP equals to? What will be OP equals to? Using again Pythagoras theorem, it will be root of A square plus R square. Is it not? Students, look here. Have you understood this? This is the horizontal component. So cos theta will be what? From this triangle, or you take from that triangle, because E1 is equal to E2. So from trigonometry, cos theta is what? Adjacent upon hypotenuse. That is OA divided by OP, where OA is A and OP is this distance, hypotenuse. So using Pythagoras theorem, again I will get this as A square plus R square, here under root, because there was AP square. So shall I again further reduce it? Can I write A square plus R square 1 by 2? Clear? Are you understanding? Are you following whatever I am teaching? Okay. Now I'll erase this part, or else I'll erase this upper part. Now go on equating the terms into it. Now students, I am interested to find electric field E at a point P, which is due to the dipole. Now 2 times, what is E1 equals to? 1 upon 4 pi epsilon naught Q divided by E1. What was E1? A square plus R square. Yes or no, students? And into cos theta. What is cos theta? Into A divided by A square plus R square 1 by 2. Correct? See here, students, this is E equals to 2 times E1 was this, if you refer the diagram, and cos theta is this. So shall I erase now this? Okay. Now look carefully here. E equals to, now go on reducing it, 2 times QA, I'll multiply this, QA 4 pi epsilon naught. Now use the law of indices. A square plus R square, A square plus R square. So this terms get, nothing is there, means this is 1. So this is what? A square plus R square. It is like in the form of A raised to power M into A to the power N. This will be what? A M plus N. So A to the power M, A to the power N. This will be what? A M plus N. So 1 plus 1 by 2. Yes or no? So 1 plus 1 by 2 will be what? 1 plus 1 by 2 will be what? 2 ones are 2, plus 1 3. So directly shall I write 3 by 2? Correct. Now students, you want dipole, and if you remember the definition of dipole, what is dipole? P is equal to Q into 2A. Yes or no? So look into my equation. P is equal to 2QA. So shall I directly write it as, and multiply 2 here directly here. So this will be equal to P. This will be equal to P. So P divided by 4 pi epsilon naught A square plus R square 3 by 2. Yes or no? So this is the electric field due to dipole at an equatorial line. So you can stop a derivation here, or you can further write the condition. So as I told you, if A is if A is, see here students, for that also you have to refer this diagram. So this distance A is very less compared to this distance. Are you understanding? So if A is very less than R, or R is very greater than R, so shall I write then A square plus R square is nearly equal to R square only. See here students, this distance A is negligible compared to this distance R. Okay, A is very small here. So shall I write A square plus R square? This small distance to this big distance will not make any more difference to this R. So shall I reduce A square plus R square is nearly equal to R square? Yes, I can do that. So remember this condition and equate in this formula. So again go on solving. E equals to P divided by 4 pi epsilon naught. Now what I have done, A square plus R square is nearly equal to what? R square. So this will be equal to what? R square 3 to the power 2, 3 by 2. Now again go on solving this. P divided by 4 pi epsilon naught. Now look here, 2 3s are 6. See here, you have to solve this. How will you solve this? 2 3s are 6, and 6 divided by 2 will be what? 3. So this will be what? R cube. Clear? Are you understanding? Okay. So this is the electric field due to dipole along the equatorial plane. So this is the required equation. Sometimes in the exam they will ask you, show this in vector forms. How will you show? E equals to P divided by 4 pi epsilon naught R cube into R cap, where R cap is what? Unit vector pointing from minus Q to plus Q. Clear? Okay. So this is the required equation. So from this you understand very important thing, that electric field E is inversely proportional to the cube of the distance. Okay, it is inversely depending on cube of the distance. So if the distance is huge, okay, then electric field varies inversely. So common sense, right? More distance, less effective will be the electric field. Very short distance, the stronger will be the electric field. Are you understanding? Okay. Now students, we are going to study torque experienced by the dipole when placed in an external electric field. Now till now we were studying only about the dipole. Okay, and dipole were responsible to generate the electric field along the equatorial line as well as along the axial line. Now what if the same dipole is placed in an external electric field? What will happen? So that external electric field will exert certain force on that dipole. As a result, the dipole will experience a torque. What is a torque? Where you have heard the word torque? In first year you have studied torque in rotational motion topic. So what is the difference between torque and the normal force? If you remember the Newton's laws, what Newton said in second law, the rate of change of momentum is directly proportional to the applied force, and it takes place in the direction of the applied force. So common sense, right? If I apply the force on this marker, the marker will go in this direction. But what if the body is pivoted at one end? So if I apply the force here, instead of body undergoing a linear motion, the body is experiencing the rotatory motion. So this rotational force is because of the torque. So basically torque is nothing but what? A rotational force. How you calculate torque? Torque equals to R cross F, which is a good example of cross product. Okay, two vectors multiplying giving one more vector is a cross product or a vector product. Now students, see and understand, I have a dipole. Again same thing, minus Q plus Q plus q separated by a distance of 2a. Let this be a dipole center, so that this distance will be a and this distance will be a. And we have already found what is the electric field along the axial line and also perpendicular, that is equatorial. Now what is happening here is we are taking help of external electric field. So a third player is coming into a play here, and that third player will exert force on this, and as a result the dipole will experience a rotational motion. So we are going to find what is the torque experienced by the dipole when that dipole is placed in an external electric field. So suppose an external electric field is coming in this direction. I'll show it a little bit. So you can imagine this, okay? There is a dipole which is placed in an external electric field. Now students, what will happen? This electric field will exert force on this electric field in this direction. Now students, this charge will experience a force of plus QE along the direction of the electric field, okay, because it is positive, and this charge will experience a force of minus QE in this direction. Understand the difference, students? This is minus charge, so the direction of electric field will be always opposite to the direction of the charge, and this charge will experience electric field in this direction. So students, are you understanding? As a result, they are experiencing equal, opposite but anti-parallel force. So as a result, what is generated is a couple. Are you understanding what is a couple? A pair of equal but anti-parallel forces, okay, will constitute a couple, and couple will give rise to the torque. As a result, what will happen? The body is going to experience the rotational motion. So we will going to find what is the torque experienced by this dipole. So what I'll do is, I'll draw a right angle triangle here, labeling this as A, this as B, and this as C. Remember this, A, B, and C. Okay. Now, shall I erase the diagram? You have to remember the diagram because we are going to take help of the diagram for the derivation. A, B, and C, and this is the dipole. Remember the direction of the force also. Now students, it's very easy thing. What is torque? What is torque? Torque is denoted by tau. Tau is again a vector quantity. So torque is nothing but force into perpendicular distance. If you remember this, force into perpendicular distance. So roughly I'll show it. This was A, this was C, and this was B. And the force experience was in this direction, plus QE या फिर minus QE. Both are same but opposite in nature but equal in magnitude. Now students, apply that formula here. Torque equals to, what is force? QE. What is force? QE. And what is this? Perpendicular distance is BC. Now this is which component? The vertical component. So which trigonometric functions will be convenient here? Sine function. So I'll write it here. Sine theta. What is sine theta? Opposite upon hypotenuse, that is BC. This distance was 2a, okay? BC divided by AB. Correct. So from this, what will be? BC equals to sine theta AB. या फिर AB sine theta, I'll write it as AB sine theta. AB sine theta. Now students, what is BC here? BC will be what? AB sine theta. So AB is 2a and sine theta. So BC is equal to what? 2a sine theta. BC is equal to what? 2a sine theta. Now substitute in this formula. So perpendicular distance is BC. Okay. So torque will be equals to QE into, what is BC? 2a sine theta. Right? Shall I erase this so that it doesn't confuse you? Okay. So QE, see, force into perpendicular distance. So BC is what? 2a sine theta from the diagram. Okay, or else I'll write here. This was A, B, C. Where was this distance? Was 2a. And from this, what did I got? Sine theta is BC divided by AB. Therefore, BC will be how much? AB sine theta. Therefore, BC is equal to 2A sine. You did not show this in exam, but for understanding you can write in your notes. So, torque is equal to 2A sine theta. So, now you are finding what? Dipole. And what is the definition of the dipole? What is dipole? P is equal to what? Product of one of the charges and the distance. So Q2A. So Q is here, 2 is here, A is here. So shall I write this as P? What is left? E. PE sine theta. So for theta equals to 90 degree, torque will be maximum. So sine 90 will be how much? Sine 90 will be equals to 1. So torque is equal to P cross E, which is a good example of cross product again. So torque. What is the torque experienced by the dipole? That is P cross E. Have you understood this? Very easy derivation. You can expect it coming for 2 or maximum 3 marks. Okay, but you have to understand the physics behind this. Clear? Have you understood this? So what did I got? Torque. Torque equals to P cross E. Okay, we'll stop it here, and next class we will going to study Gauss law and its application. Thank you.